Hello, this is Rich Lamb. For my midterm practical, I'll be explaining a little of my knowledge on the vertical jump. The movement description, essentially is a full body movement that relies mostly on lower body or the extremity. This movement mainly is for lower body power for jumping as high as possible from a standing position. At the starting phase, you stand about shoulders width with the knees slightly bent with the arms raised up. In the counter movement phase, quickly transitioning into a quarter squat, shifting the hips back and swinging arms down simultaneously. Then in the propulsion phase or the concentric phase, push off the ground explosively, extend your knees, hips, and ankles. Last but not least, land on the balls of your feet safely to prevent injury. For the anatomical breakdown, in the eccentric phase, coming down, absorbing eccentric forces, storing elastic energy in a short amount of time, hips or torsos are acting as a shock absorber, helping minimizing any excessive eccentric forces in the connective tissue and skeletal structures. The muscle that involved would be the gluteus maximus, with the origin of the outer ilium, posterior side of the sacrum and coccyx, and part of the sacrotuberous and posterior sacroiliac ligament, with the insertion of the gluteal tuberosity of the femur and iliotibial tract. The action that accelerates during hip extension and decelerates during hip flexion. The rectus femoris origin will be the AIS of the pelvis, insertion base patella tibial tuberosity of the tibia, and the action accelerates during knee extension and hip flexion, and decelerates during knee flexion and hip extension. For the gastrocnemius, the origin will be the posterior aspect of the lateral medial femoral condyles, insertion being the posterior surface of the calcaneus, and the action usually accelerates during plantar flexion and decelerates during dorsiflexion. During the amortization phase, quickly transitioning from eccentric power to concentric power, requiring the max stored elastic energy. The muscle that involved the gastrocnemius, this being the posterior aspect and lateral medial femoral condyles. Again, the insertion being the posterior surface of calcaneus. The action is isometrically stabilizing the foot and ankle complex. For the semimembranosus, the origin is the ischial tuberosity of the pelvis, with the insertion of the posterior aspect of the medial condyle of the tibia, the action being stabilizing the lumbopelvic hip complex and knee. And the vastus medialis, origin being the lower region of the intratrochanteric line, medial lip of linea aspera, proximal medial supracondylar line of the femur, and the insertion would be the base of the patella and tibial tuberosity of the tibia, with the action stabilizing the knee. Last but not least, the concentric phase. Muscle involved of the gluteus maximus, the rectus femoris, and the gastrocnemius again, but the actions for the gluteus maximus, action being accelerates during hip extension and decelerates during hip flexion. With the rectus femoris, the action usually accelerates during knee extension, hip flexion, and decelerates during knee flexion and hip extension. For the gastrocnemius, the action is accelerates during plantar flexion and then decelerates during dorsiflexion. For the functional anatomy analysis, during the vertical jump, the body utilizes something called the stress joining cycle, which essentially helps absorb eccentric forces and transitions from eccentric to concentric as fast as possible, with the mechanism of combining neural pre-activation, the stress reflex, and also the elastic recoil of the tendons. This movement requires a lot of triple extension of the hips, the knees, and ankles. The required range of motion during flexion of the knee is from 87 to 107 degrees. For the hips is roughly around 90 to 120 degrees just depending on the trunk length. And then the ankle joint during dorsiflexion is around 20 to 30 degrees. Now for the extension part, the hips usually around 59 and 58 degrees during total extension. The knees range of motion will be around 78 to 82 degrees during total extension, and then the ankles during plantar flexion it will be around 63 to 65 degrees. Extensibility. For the vertical jump, it allows our muscle to stretch at its optimal length without injuring ourselves to produce maximal force. Elasticity being our body's ability to store the elastic energy from our tendons and agonist muscles and act as a spring to quickly release the stored elastic energy. And then the contractility, the agonist muscles rapidly shortening due to the stress shortening cycle to develop high force and velocity. Now the biomechanical principle, in terms of kinetics, the ankle will act as a second-class lever during plantar flexion. The knee and the hips during extension will act as a third-class lever, which essentially for the third-class lever is just the effort being between the fulcrum and the load. For P-torque of the hips, ankles, and knees will contribute to total force production. And this also, during the vertical jump, it will also produce high vertical outputs through hip and knee extension. The internal forces that are involved will be the muscle tension and contraction of the lower extremity. For the external forces that are involved, it will be gravity and the vertical ground reaction forces, which refers to Newton's third law of action and reaction. For kinematics, sagittal plane movement, it acts as a sagittal plane movement. And the axis of rotation will be the medial and lateral axis. The movements in the joints will be knee and hip flexion and extension, and ankle is dorsiflexion and plantar flexion. Us measuring our forces. Force place will be the gold standard. This helps us provide precise kinetic data on force time and power time. Velocity-based training devices helps us measure the bar speed, which gives us an idea of how much power we can produce, but it's not as ideal as force plates. And jump and switch mats, this helps us to measure flight time to help us better calculate jump height. For the application, common insufficiencies will be poor neuromuscular coordination, poor landing absorption, and weak glutes and hamstrings. This will lead us to ankle sprains, ACL tears, and patellar tendonitis. For training recommendation, I recommend developing max strength in the lower body. So getting stronger in movements such as squats, barbell squats, hip thrusts, and RDLs. Then incorporate plyometric training. This will help us improve neuromuscular coordination and help us with landing mechanics and absorption. So rely or incorporate depth jumps, box jumps, and pogo hops. For training intensity, I recommend keeping the volume low, but keeping the reps high intense, just to really get really high quality reps for each rep as much as possible. And last but not least, for recovery, allow 48 to 72 hours of rest in between the training sessions to allow your nervous system and your muscles to fully be rested and be fresh for the next training session. And last but not least, it'd be my references for all my information. Thank you.